Welcome, students. For the next week or so, we're going to study sequences and series, and today we're going to have an introduction to sequences. Roughly speaking, a sequence is an infinite list of numbers. We will often represent these as a sub 1, a sub 2, a sub 3, a sub 4, etc. A simple example of a sequence is the following: 5, 10, 15, 20, 25, etc. In this case, a sub 1, or the first term of the sequence, is equal to 5. A sub 2, the second term, is equal to 10. A sub 3, the third term, is equal to 15. A sub 4 is 20. A sub 5 is 25. And we haven't actually written it out yet, but if we wanted to, we could say a sub 6 is 30. And we can recognize this by recognizing the pattern. These are multiples of 5. And we can see that a sub n, referring to the nth term, is just 5 times n. This is the formula for the sequence. It tells us how we can get any element. For example, the fourth element is 5 times 4, which is equal to 20. We can consider a sequence to be a function. And in fact, that's how we define what a sequence is. A sequence is a function f whose domain is the set of natural numbers. So instead of having a function that's defined for any values, we have a function that's defined at 1, at 2, at 3, etc. And when we evaluate the function at these values, these are called the terms of the sequence. Now, we don't usually write f of 1, f of 2, and f of 3. We usually write a sub 1, a sub 2, and a sub 3, etc. Because if we write f, that confuses things with the sorts of functions that we've already looked at. This is a very special type of function. It is only defined for 1, 2, 3, 4, 5, etc. And so generally, when we're dealing with sequences, we call the terms a sub 1, a sub 2, a sub 3, etc. This shows that we're specifically working with a sequence instead of just any of the functions that we've seen earlier. I want to start now by looking at a couple of examples of sequences. So first, let's consider a sub n equals n squared minus 1. If we want to figure out the elements, we can use this formula to figure them out. So a sub 1 is going to be 1 squared minus 1. 1 squared is 1, and 1 minus 1 is 0. So the first element here is 0. For the second element, a sub 2, that's going to be 2 squared minus 1. 2 squared is 4, and 4 minus 1 is 3. Next, for the third element, we have 3 squared minus 1. That's going to be 9 minus 1, which is 8. Then the fourth element is 4 squared minus 1, which is 15. A sub 5 is 5 squared minus 1, which is 24. And so if we were to write out the first few terms of this sequence, we would have 0, 3, 8, 15, 24, etc. We could figure out further numbers in this sequence. If we wanted a sub 100, we could take 100 squared minus 1, 100 squared is 10,000, and 10,000 minus 1 is 9,999. If we're given the formula for a particular sequence, that's all the information we need to figure out any element in the sequence. Let's take a look at another example of a sequence. This time, let's consider the sequence B sub n. It doesn't have to always be A sub n. We can use different letters. B sub n equals -1 to the nth power over 2 to the nth power. Just like the last one, let's evaluate the first 5 elements so we can see what this sequence looks like. B sub 1 is going to be -1 to the first power over 2 to the first. -1 to the first is just -1, so we've got -1 over 2, which we will write more commonly as -1/2. Let's take a look at the next element, the next term. B sub 2 is -1 squared over 2 squared. -1 squared is +1 because a negative times a negative is a positive, and 2 squared is 4. So we've got +1/4. Let's look at the third term. This is going to be -1 cubed over 2 to the third power. -1 cubed is going to be -1 because a negative times a negative times a negative remains negative, and then 2 cubed is 8. So we've got -1/8. If we look at the fourth term, this is -1 to the fourth power over 2 to the fourth. A negative to an even power will be positive, so the numerator will be +1, and then in the denominator 2 to the fourth is 16. And let's look at the fifth term. I think looking at 5 terms is usually good enough to see a pattern. We've got -1 to the fifth over 2 to the fifth. A negative to an odd power is negative, so we've got -1 over 32, or -1/32. So if we were to write out the terms of this sequence, we would have -1/2, +1/4, -1/8, +1/16, -1/32, and so on and so forth. And I want to point something out here. This -1 to the nth power causes our terms to be alternating between negative and positive and negative and positive and negative. If we ever have a sequence that has a -1 to the nth power, or a -1 to the n plus first power, or a -1 to the n minus first power, all of which are common in sequences, these are going to lead us to have an alternating sequence. Meaning that the terms switch between positive, negative, positive, negative, or negative, positive, negative, positive. In the next video, we're going to continue looking at examples of sequences, but for these examples, we're going to be given the first several terms, and it'll be our job to figure out what the general formula is for the nth term.